supercomputing documentation. And if you look for, where is it? You can search, you can simply search MWA Cetonics migration guide. And we have this page set up for MWA researchers, illustrating the main differences between Garavala and Cetonics, and a few high-level suggestions on how to work with these differences and how you can use Cetonics in general for radio astronomy computational workloads. Can people online listen to me? Can you hear me? Show hands or anything?
Can someone unmute and confirm? Annie?
Okay. Wait.
Edwin, are you able to hear us?
Is it okay if I record?
Okay. Thanks, Sam.
Thanks, Sam.
Yeah.
Okay.
Yes, we can
So
hear you.
we have this page on our documentation which condenses all the information you need to get started on Cetonics, but today we're going through various modules of our supercomputing training. And these modules are designed specifically to illustrate how Cetonics works and how you can use it to run your workloads. Along the way, if you have questions, if you see differences with Caravalla, just raise your hands and speak about it, interrupt me at any time if you have questions, and Deva and I will try to answer. So there are, the training takes place over 2 days. So we have the first day 9 to 12 and tomorrow 9 to 12 as well. We have around 6 modules today.
Yes.
And then 5 tomorrow, right? And these are targeted to people with a wide, with a wide range of experiences. So there are some topics that might be very at the introduction level. Some of other topics might be more advanced. In general, it's an introductory training. So if there are things that you're very comfortable with, I imagine many of you already been using Garavala and supercomputers. You're comfortable with Bash and Linux basic stuff. I try to skip over those parts and try to get to the important points we want to discuss.
Yeah, we can see that most of the attendees are users already.
Yes.
So there's some basic exercises like Hello World and everything. So we don't need to do all those things.
Yes,
But if you feel it's important,
more time
yeah,
to questions and to
advanced stuff like
advanced
we can
topics.
as it
So
comes
that's what I
along.
was thinking.
Because the slides are already available, I believe, online.
Yes.
But we can discuss. Like, if anyone has questions, please
Yes.
Raise your hand in the action on the Teams, and then we can discuss. It's like, let's make it as more interactive.
Sure.
Because
Yeah.
everyone is an advanced user here.
Okay. So everyone is fine with us recording the meeting?
Yes, I started.
You started. I can see. Yeah.
Can you see the
Okay.
red button on the top?
Yeah, I can see it's recording. All right. The first module is simply an introduction. I show. All right. These are the modules we are going to present. This will be an overview of our supercomputing facility, in particular Cetonics. The second module is going to illustrate how you can log in on Cetonics, a very simple module. Then we have file systems overview, moving data in and out, which is particularly important for you MWA users, and then using software. The second part is using the software already available on Cetonics, and now you can install new software yourself and containers. So this is what we cover today in the first column, and Deva and I will alternate in presenting the modules. I will do the first 2, then Deva will present the 3 and 4, and then 5, 6 on me. Throughout the presentation, we have a few icons on the slides. I mean, they have different meanings. We have a symbol, for instance, for definition of new concepts. We have best practices, warnings, things you have to keep in mind when using Setonics, also best practices. We have throughout the slides, we links to the user documentation. Everything we cover here is already documented in depth in our documentation. So any information you need for information, you can access it on our documentation. We have also a few exercises along the way, but they are basic exercises since all of you have already used supercomputers. Aside from things that are specific to Setonics that might be worth looking at, I think we can skip a few of them, but let's see. Okay, well, this is more for an introductory person, but the way we start this presentation is how many calculations can you do in a second, right? So usually Fatima runs the slide, takes 1 second, and see how many calculations you manage to do in this time. Then you try again, and the point here is that there's only so many computations you can do. Like one of those operations, we indicate them like a floating point operation because usually you work with floating points. But the point here is that as nowadays computers have a huge capacity of performing computations at a very large scale and in a very fast way. So we measure the power of a supercomputer in terms of how many operations it can perform per second, and this is called floating point operations per second, or flops. A supercomputer nowadays can run in the petaflop scale, that is 10 to the 15 operations per second, which is a huge number. The Setonics has a capacity of 43 petaflops, whereas Garavarna had a capacity of 0.5 petaflops, around 0.5 petaflops. So this is a significant increase in computational power researchers have access to. Yeah.
Just a silly question, but is that just basically proportional number of nodes available? There's just more nodes on Setonics.
So it's not as easy because most of the computational power of Setonics comes from the GPUs. So there's around 90% of the flops comes from the GPUs. So although we have fewer nodes, we will see we have around less than 200 GPU nodes. They are packed with GPUs and they provide more computational power than the 1,500 CPU nodes we have on Setonics. In general, this is just a quick overview. We have a few supercomputers. This is the list of the top supercomputers or public research supercomputers in the world. The first two are in the United States, and the first one is Frontier. Actually, just yesterday, this has changed.
A bit outdated, like by 2 days now, because the new list has come.
There is there is the supercomputing conference in the United States. And they presented El Capitan.
Yeah, El Capitan is now the number 1.
It's the number 1.
And Frontier became number 2. Yeah.
With 1.7 exaflops, whereas Frontier has 1.2 around.
Yeah, 1.2 exaflops.
Exaflops. So we are actually not anymore in the petaflop scale. Well, most of the world is still in the petaflop scale, but the United States made the leap into the exascale, and they managed to do that because of the high density provided by computation provided by the GPUs. Gaudi is around 100 in the top 500 list at the moment, and Setonics at the moment is number 28.
So Gaudi didn't have a recent uppoint first, right? Did they?
It should be. This ranking is a June. So if they had this upgrade, the upgrade though was on the CPU side, right?
Okay.
Right.
That's
Yeah.
That's what my understanding.
Yeah. So probably because the many supercomputers are using GPUs. They have more compute density. Even though it got upgraded, it was not enough for it to push through.
So now the Pawsey Setonix is number 45.
Okay. Oh, okay. As 2 days ago.
It keeps changing.
How often do they update?
Every 6 months.
Every
Every 6 months they release the new one. So one during the supercomputing conference in November, another one is ISC in Germany. So that happens in May, June. So every 6 months you get a new one.
All right. We support a wide range of science with Setonix and with previous supercomputing system. Of course, we support the MWA researchers with the astronomy workload and astronomy workloads, but we also support health, agriculture resources. We have many people running computational fluid dynamics for simulations for various science cases. We have big users in atomic simulations, which is Igor Bay as well, one of the bigger groups. So we support a wide range of sciences with Setonix. This is a high-level view of what makes up a supercomputer. We have cabinets, which each cabinet contains compute chassis. Chassis hold for Setonix, they hold around 8 compute blades. So we have 64 compute blades per 64 compute blades per cabinets, I believe. And each compute blade contains 2 nodes. So and each node for the GPU partition contains 4 GPUs. So you can see that the compute density in each cabinet is quite high. And the problem with the compute density is that you need to cool down the infrastructure at the compute blade at the node level. So you have a very complex system of cooling made of pipes that go into each blade. You can see that the network of pipes that is needed to cool down the blades is quite dense as well, as it is the interconnect connecting all these compute blades. At the logical level, a supercomputer has plugin nodes, as a scheduler, compute nodes, high-performance storage, and data movers. This is at the high level, not different from what we have in Garavarla. So we have the same scheduler. We have more login nodes and way more compute nodes than we have available on Garavarla. Can I just move through this? Just skip through this because this is just introductory stuff. But one thing is interesting to notice is that this is an actual picture of Setonix, I think closer to when it was being installed, and you can see that this is the view that shows the interconnect connecting the various the switches to the compute blades and the nodes, so that they can enable the communication across nodes. And in particular, the interconnect, we have a few images here. The interconnect is configured such that each node is just 3 ops away from every other node. And this is called the Dragonfly topology that was developed by H.P. Gray. And if you think about the number of nodes available, compute blades available on Setonix, it's quite impressive. This requires a high density or a high number of network links to connect all this together. And this is done to reduce latency. And this is also the reason why the supercomputer has to be packed, because unrolled all these network cables, they're quite long, and that can also increase latency. If you have very big supercomputers, then latency can be a problem in connecting the various nodes. So there was a lot of thinking in designing the network here. This is a very simple diagram illustrating what is in chassis. Essentially, we have compute blades. We have 8 compute blades for each chassis. And each compute blade has a 2 node. Nodes are we can see them at the front. We have them in exposition. Well, we have 2 nodes. We have 2 nodes cards, and each node card has 2 nodes inside. So I was wrong before. We actually have 4 nodes for each compute blade. But it really depends also on whether it's a CPU, whether it's a CPU node or a GPU node, because the hardware path on the node is different.
Somewhat right, because there were 2 node cards, and each node card has 4 nodes.
Okay.
So yeah.
On the CPU side, the CPU we have, one difference with Caravalla is that now we do not have Intel CPUs, we have AMD CPUs. AMD CPU is different in the previous, in what we have on Caravalla. One major difference, then the number of cores has increased. So we have each CPU has 64 cores. The 64 cores are grouped in 8 dies, or what they call Zen CCD, and 8 cores share L1 or L2 cache. So they form we configure them to form a NUMA node. And they 8 cores, they share the same L1 cache and L2 cache, but then we have also them connected to a bigger memory, so an L3 cache.
L3 cache is the purple one in the middle.
Oh, okay, right.
Yeah.
Sorry, yeah. So we have, so each core has an L1, L2 cache, and then the 8 cores share the L3 cache. And the L3 cache is 32 megabytes. And one thing you will notice is that to get performance on the CPU, you have to organize your computation such that threads accessing closed memory locations maybe have to group they have to land on the consecutive 8 CPU cores so to obtain maximum performance. Whereas in the previous CPUs, you had less L3 cache, but it was shared across all the CPU.
More CPUs.
CPU
On
cores.
Caravalla, there are 2 NUMA nodes.
Yes.
And 20 and 20. So whereas here is 8.
Yes. So you have more CPU cores that allows you to access. You have more flops available, but you have to take care of the fact that the L3 cache now is, let's say, more fragmented. You have more L3 cache, but it's localized to 8 cores rather than 20 cores. So it means that your computation the placement of your of the threads on the various cores can have an important impact on performance.
So the per node or per core, there's still more L3 cache, right?
Yes.
Okay.
There is, because we have more cache.
Yeah, bigger L3 caches, I think.
Right.
I don't recall for the.
But you won't get maximum optimal performance unless you decide those particular cores have to be like that doing the computations.
Yeah, the
in some
placement.
sort of a coordination.
Yeah, the placement does really matter. So, but Slurm takes care of trying to assign them equally, but don't try to go with odd numbers like 1, 5, 7, 9 like that. But so we recommend users to go in multiples of 8, so that, and then the Slurm will say, okay, 8 requests are coming, so let me put in the in the same CCD. The CCD stands for core chiplet die, which is the important term to remember.
Yeah.
CCD. Normal people say CCD, but
Yeah.
it stands for core chiplet die. So
Okay.
we just got 8 cores. So on Cetonix, it's good to have a practice of requesting in terms of multiples of 8.
Yeah.
Like if you're running an OpenMP shared memory parallelism code, try with normally the scaling benchmarking 2, 4, 8, and go up to 16 as well and see whether it can do like 2 CCDs form a NUMA node. Isn't it? So two CCDs, that is 16 cores form a NUMA node.
Oh, okay.
And,
Because I think we tried different configurations,
Yeah.
and then I think we first tried with one per CCD, and
CCD.
then we just ended up having two.
Two.
Okay. So the bottom line is that the thread placements of the cores can play an important role, depending also on the access pattern of your application, can play an important role there.
I check you've got aircon, which you do not. Actually, you don't.
And this is a view of the GPUs and the GPUs on Cetonix. On the left, we have a picture of, or a render of the blade of the blade containing 2 nodes. So this is a GPU blade. So as I was saying, GPU blade has 2 nodes, per blade, because the reason is we have 4 GPUs per node, taking up quite a considerable amount of space here. So these are the 4 GPUs per each node, and then we have this is the memory, I believe. We have also the CPU on this side. GPUs, we will on a high level, as a high level description, and each GPU on Cetonix, a GPU on Cetonix, the MI250X, and then we say there are 4 GPUs per nodes. Each GPU though is designed to have 2 logical GPUs on it. Let's say they call it graphics compute die. Just like the chiplets on the CPU, that the CPU, the cores were grouped by 8 cores per die CCD. In this case, we have graphics compute dies, which each holding a chiplet. We call that is basically a GPU, two logical GPUs forming an MI250X GPU. The reason for this design is that having 2 GPUs, or like 2 chiplets on the same board allows faster access to the memory, the same memory. So two logical GPUs sitting on the same physical board will have faster access to the memory than 2 GPUs that sits on different boards. And and also it's a design decision also regarding the power consumption, what you can actually physically achieve in terms of compute. So essentially resulted in designing two GCDs, which on SLAM are seen as a standalone GPU. So a GCD is what you actually request as a GPU on SLAM when you run your compute. So as far as your program is concerned, what you see is you have 8 GPUs per node. But physically they are 4, just each physical GPU is comprised of these 2 GCDs. And this has an implication in terms of access to memory, to GPU memory, and energy consumptions, and the way the energy is distributed across these chiplets. It was an engineering decision to have this kind of design there. Each GPU die, we can also say a logical GPU, has 110 compute units. A compute unit is what in the NVIDIA terms can be called a streaming multiprocessor. And the Volta has, I think, around 80 streaming multiprocessor. So the GPUs on Caravana and around 83 multiprocessor. And each compute unit has or 3 multiprocessor. In the case of Volta, has some what in CUDA or NVIDIA as they're called GPU cores. We call them stream processors on the AMD GPUs. So the architecture, without going too much into details, the architecture, the way you use the GPUs is rather similar to, at the hardware level, the design is rather similar to the at the logical level to the NVIDIA GPUs, except for the fact now on Cetonix you have 2 logical GPUs per on the board. But when you use it on through SLAM, you request it to SLAM, you'll see 1 logical GPU can access 1 logical GPU. That is your unit. And so in practical terms, the major change for you will be the software the language you write your program in. But the programming paradigm you use to program GPUs is the same.
Just clarifying one high-level
Yeah.
information. So earlier you said that the faster memory access.
Yes.
That's one thing to watch out. So this particular thing, and does it have like any important implication in the way that you would do the coding or for proper optimal performance?
So this matters when you use multiple GPUs. Also, and one thing, when you use multiple GPUs and you have your program that use 2 GPUs and these 2 GPUs communicate with each other, you want to place your computation such that the communication happens between the 2 GCDs on the same chip. So if they access the memory that is placed on the same physical board. If you use a single GPU, doesn't have any programming implication at the programming level. One thing that also is good to mention is that there is associations between GPUs and CPUs in terms of how the GPUs are linked to the CPUs in the memory. So meaning that when you transfer data from CPU memory to GPU memory, you can do any transfer from any CPU to any GPU memory, but it's faster when there is an association between GPU and NUMA region on the CPU, such that the memory transfers are faster if the memory of the CPU and GPU, let's say, are directly connected, and they don't have to, the memory transaction doesn't have to pass through other CPUs to get to the GPU. So there is, usually our placement is organized.
Yeah, we have had the SLAM.
SLAM will handle that, but there might be some cases where if you mess around with the pinning and stuff, you have to
specify
that yourself. But in normal cases, that is handled for you.
Okay.
So there are 64 cores on the GPU nodes, CPU cores, and there are 8 GPUs. So as we said about the CCD, it's an 8-core chiplet die. So each GPU is attached to one of the chiplet die. So if it happened like that, not necessarily the GPU 0 is attached to the first CCD. It's gone up to 7 or 6, right? And it's a different numbering. It's in the documentation pages. So they're in random order. So we try to, whenever some user requests a GPU, automatically they will allocate 8 CPUs, which are attached to that CCD. So each GPU is attached to a CCD, so it automatically goes there and picks that one.
Okay.
Okay. This ends the overview part. So we're just trying to go to this other one. So the second one is about logging in. Online, if you have any questions, you can unmute yourself and just ask.
If you have any users around you, Sam and Ashwin, please bring them in. So share the meeting link and ask them to come in.
Yeah.
It's we're gonna, like, as we progress into the modules, we're going to go into that one. So It's more.
Okay, the second module is about logging on Cetonix. I'll be rather quickly because there is, it's of course a remote access, just like Garavarla. We have logging nodes, we have more logging nodes than Garavarla. Some of them are dedicated to, some of the logging nodes have been repurposed for to be workflow nodes running workflows such as Nextflow, but we have in general more logging nodes than Garavarla, but they work the same way, and they all can be accessed through SSH using the SSH command username at cetonix.pawsey.org.au. So those name, of course, changes from Garavarla to Cetonix. But the SSH way, or the way you connect to the supercomputer is the same as Garavarla. Nothing new here.
So the Pawsey supercomputers you can access from anywhere in the world. Like it allows both incoming and outgoing traffic. So anyone, it doesn't sit behind a firewall. So it's just like Garavarla, how you can access from anywhere. So
Yeah.
no restriction. The only condition is if you keep on entering multiple wrong passwords, your IP will be blacklisted. Then you have to try for another IP or wait for some time.
Yes.
So that's how we block the hackers, like those who try to try the brute force method to get into the system. So
And-
block.
and-
Or those who just keep typing their password wrong
Yeah.
accident intimidation.
On that topic, when you have trainings, you need to organize some training with many users and they all connect to the same place. That could be seen as an attack to the system. So if you organize any training or anything, just let us know in advance, and so we know we expect a lot of connections from the same IP. Just like, for instance, at the radio school this year, we had to unlock the IP because it was blocked. We identified that fairly quickly early on, and we managed to move.
So we put a long password and people just L and 1 just confuse and then enter, and they're all coming from the same IP. Like
Okay, so I assume everybody has access to Cetonix, and we'll need to go through these simple exercises, I imagine.
Have you? There are 2 people online, and have you got a chance to log into the Cetonix? You will see Natasha's Quokka there, and you can say hi to that. That's what.
Is there a?
Yeah, that's what Natasha. Like we ran a competition, like just to see who can
yeah,
design the
okay.
best Quokka, and
Sorry.
it is Natasha's.
No, I didn't realize that.
Yeah.
There it is. I'm not sharing mine because I'm sharing the.
Oh, your screen. So yeah, you can see this one.
Let me share.
Yeah,
this.
I'm not seeing that by the way.
Oh, you have to scroll up a little bit.
Oh, really? Okay, I'm just doing it. I have done it before, but maybe you have not paid attention. So this is my, this is the comment,
Yeah,
right?
okay.
Yeah.
Oh, we do have anyway.
Oh, yeah. Okay.
The
all right,
slides
okay,
here.
yeah.
This is it.
Yeah, since you're into all the MWA people, I'm telling the secret. Normally, if it is general, I won't tell about it. Yeah.
Okay. Another thing you may notice is that there are a few environment variables set that I'm not sure whether they're present. On Garawana, we do have the my scratch environment variable, but you do not have the my software environment variable. That will point to your personal location where you can install your software, and then and that location is specifically designed for you to install your software there. And we do have also other locations where you can install software for your whole group. I will discuss later during the software installation thing is that installing software on Cetonix is different than on Garawana because you won't be able to install your software system-wide just like you did on Garawana under the Pawsey system. We do not have the Pawsey system anymore, but I will discuss it later.
Yeah, there are some admin people, those who are allowed to install /Pawsey on Garawana, but here it's only up to the project wide at the moment.
Here an example of the content of those variables here.
Okay, someone waiting to.
There is someone waiting.
No, I
Okay. Another variable that is present on the system is also often not known, but we have the Pawsey cluster variable, Pawsey underscore cluster, which prints the name of the system you're on.
Is there a list of like a page on the policy help documents that has just a list of all the
Variables, yes, there is.
Okay.
Yeah, if you're part of multiple projects, like, say, but it will, the My Scratch or My Software pick up the default project ID. So there is a default project ID for each person. So if you want to go to another project, then you have to go to the absolute /scratch, the project
So
ID.
and that file is under your home directory. So it's under .pawsey project underscore project.
There is a hidden file, .pawsey project. So that shows the default.
And by modifying the content of that file, you can choose which one is your default project.
You can run a cat.pawsey project in your home space. So that is your default project. So you can change it.
You can change it. You will have to log out and then log in again for the change to take effect. And so that will affect the software you're using available if you have installed software under your project or under your username, because your personal directory sits under your default under your project directory. If you're part of multiple projects and you have multiple personal directories depending on the project, and so as such, the module system is set up to show the software you have installed in the current active project you have selected. We already talked about for passwords and common login problems. We have different policies to protect the systems, and based on for security reasons, we will block the account or the login to account if there are multiple unsuccessful login attempts. You can unlock your account just submitting a ticket to the help desk and prove through your email, proving your identity.
Yeah, provide the IP address. Like,
IP address.
Yeah, if you can Google what is my IP address, it will show the IP address, and then we can.
This is not different from what was happening, I guess, on the Aravarla.
Previously on our systems, we used to block them for indefinitely, but now there is a time limit based on the number of attempts. Like maybe if you got 3 attempts, that 20 minutes time limit.
Okay.
But 4 means it goes up. Like, the next time after 20 minutes, if you go the 4th attempt,
okay,
it shoots up. So yeah, try to make sure the passwords are correct.
Yeah. I usually get careful when I anywhere when I try to log in. If I get the first one, okay, I better watch out. Second or third. No, that's how all the banks do it, right? They only allow like 3 attempts.
Yeah, I
So that
what we suggest in general is to use SSH keys, so that set up SSH authentication, and the problem won't be there anymore. Okay. You can also open GUI applications on the system. You will need to log in on the system by enabling X11 forwarding. We do also have other visualization services. So if you have to have a very computation expensive visualization to run, you can use the remote viz service at Pawsey. This is one thing that Garavara doesn't have visualization services. No. So we have visualization nodes on Sertonis that are equipped with NVIDIA GPUs to run visualization workloads.
Large scale, yeah.
And you can run, they are not part of the SLAM.
They're not part of SLAM.
They're not part of the SLAM cluster. They are accessible through this web interface, and you will be provided, a GUI interface where you can launch your visualization applications.
Yes.
But it's not part of the SLAM cluster, so it's not a supercomputing. It's a visualization service, a remote visualization service.
So those visualizations are like a
rendering of meshes and visualizing simulations. We have a few astronomers rendering 2D cubes of galaxies and gases, but then they can also visualize them in the viz room on the screen.
Oh, there is a big screen here. Probably we don't know whether we got access. Yeah, we can
we
point, but we
do
can
have,
show
yeah.
from side.
Well, this is the end for the logging in section. So we can run up maybe. You don't jump with time. But if you have any questions, just ask. So far, the logging is similar to Garavara, and we will go through other modules illustrating advanced topics where things can get different.
Share. Coming through. Any questions so far from online participants? Sam? Sam has been on Garavana migration at the time. I shared.
It's probably
Can you all hear me? Oh, maybe it's muted.
it's all right.
Most of them are muted. Probably.
No, can you hear me because my screen is
Yeah,
not-
can you hear Deva?
Oh,
You're online.
One of you confirm, please. Clancy, can you hear us?
Yes, sorry, I was trying to find the unmute button.
Okay, good. Yeah, no, we
Okay.
were just checking.
yeah, because we just changed the screen in laptop.
Yeah.
So, yeah, if there is anything, please raise your hand. Like not, yeah, I mean, say on the Teams, like, there is a raise button and then we can discuss straight away. We are moving into the more in-depth now. So thanks, Christian, for the introduction. So now we are slowly going into the depth. So that is more important. So now the third module, we're going to see the file systems overview. So we'll have a quick look as there are 11 modules overall. So the first 6 today and then next 5, both are equally important. So, which is very, and I mean tomorrow the module 9 is running jobs, like, what is different between Laravel and Cetonix. It's important to know. And software modules, which Christian will be covering later. And containers, of course, MWA people are embracing containers in good, yeah, for a long time. So which is very good. So yeah, that is important one. So from this module, we'll just try to see what is a file system and try to see what are the different file system and what is different thing, and how to monitor your file system quotas, which is a big problem. So at the moment, like, everyone hitting the file limit very quickly. And some of the signs, as Christian pointed, definitions, best practices, keep an eye on these symbols, and let's try to, and warnings as well, the bad practices. Let's look at the file system. So before going into the file systems on Cetonix, let's have a brief description, like a definition of file system. So as we know that file system is it's a method used by any operating system to store, manage, and retrieve the data. So some of the file systems you might have heard the examples in the bottom. So on Linux, fourth extended file system, ext4. Apple is Apple's file system. Windows is, in the olden days, they used to be NFS, which is network file system. Nowadays, it's NTFS, new technology file system. And when we talk about the file system, so we also refer to the hardware that is used to store data. So it can be different ways, like, in the hard drives can be spinning disk, solid state drives. So nowadays in the personal computer, it comes with one of the file system. I haven't come across a laptop with multiple file systems so far. So one file system and disk drives, different disk drives. So maybe the C drive driving through the SSDs and the other drives spinning disk. So like a couple of things. Now, why are we talking about the file systems here? So file system, what is because we discussed about the top one supercomputer, El Capitan, which is has been crowned 2 days back as the top one supercomputer, reaching 1.7 exaflops. It is a supercomputer, but if the file systems are so bad, there is no point of having the best supercomputer. I hope that Devnal is not online. So he has been complaining about the file systems. I mean, say, because when you work on large data on any system, so I'm part of another supercomputer called Lumi, which is in Finland. So everyone has got the same issue with the file systems, and and there are different things. We try to
Yeah.
improve the performance of them, but it depends on both sides. The users have to do the right thing, and
Yeah.
we on the Pawsey side have to manage the correctly. So that's why we do the regular updates on the platform side. That means doing regular updates, and users have their role. Like a couple of years back, there was because when the policies were not tight, not a couple of years, maybe 4 or 5 years back, over the weekend, one user has written 1.7 billion files. Like, the policies were not like see up a user, which generates a lot of small files. There was no restriction at the time. Smashed.
Right.
The next morning, the limit is 1.9 billion inodes, the files you can. So that reach of the user has gone up so high. So that's why in order to do the both side, everyone has to do their part. It's a shared resource.
I'm just giving a one city example here. So from my understanding is that basically this is an issue that lots of people are sort of stumbling upon now. It wasn't like foreseen at the time of most of the supercomputer design.
Yeah.
Yeah. So in terms of the number of files, you are right. In the way we are processing, yes, there are lots of files generated. In some cases, at least, it is partly to do with the way the system or telescopes or subsystems are also like designed or reward. Like in the olden generation, traditional ones, that when you go to a telescope, you ask for the backend will give you like one single large file, or sometimes like breaking up into like 200 seconds. But now what's happening is like you have so many more elements, you have much higher data rate, and moving around the data becomes like much easier when you deal with the smaller files. But the smaller files has this very big scaling cascade issue because we are dealing with the next generation N element telescope. I think that is where we are seeing like take a simple example of MWA, 228 it's just increase the number of baselines by factor of 4, right? So no, much more than that. So that's the thing.
That's right. So the number of files, it's growing.
Yeah. So
exponentially, not linearly anymore. So people are
And
coming.
also with the more computational powers, you can produce more data. And so
More data.
on.
Yeah, that's right.
So that's,
So there should be equal balance between a supercomputer and the file system. So some of the, like if you talk to the vendors of a supercomputer, they don't like talking about file system and memory.
Yeah.
Why the memory is so low, why the memory bandwidth.
Yeah.
So these things, they're struggling.
Yeah.
So yeah, let's
no,
try to
the
use.
point I'm making is, strictly speaking, this is one thing that should be like possibly the part of instrument design or correlator design. That's where I think we get into the trouble, essentially.
Yeah, try to get the base around. So in order to maximize the performance of the file system and also the supercomputer, because there is no use of a supercomputer without an efficient file system. So there are various specialized for distinct purposes. So you can see the last 4 points. Some of them are optimized for read-write performance. So some of like, for when you're running the jobs, like, for to have a good read and write to pick the data from the Lustre file system and try to read and write it fast. And some are optimized for storage, which is the power efficiency, which we call as Acacia, so high availability systems. And some are optimized for shade, like, we have around 4,000 users on Setonix. And 1 or 2 users can bring down the thing. So that's why we keep the policies. The second point, we enforce the policies. Like initially we used to have a 30-day purge policy. Now, unfortunately, because of the amount of data that is coming in, we have moved it to 21 days and people are complaining. I know that, but see what you as a users, you can try to do from your side, try to reduce that one. And not reduce the data, try to, I would say, work around the base in order to satisfy the policy. And we have multiple types of file system we provide. Now, on Setonix, we have these 4 file systems which are general purpose, and one is for dedicated for ASCAP radius domain project, ASCAP buffer. I don't think that MWA people are allowed to. So say that means we need to discuss about the 4 file system, which is the one is the Scratch. Now when I share it's a bit distorted. I will try to reduce the thing. Scratch file system /software Acacia /home. I believe that you're as part of Garawala, you've been accessing home. It's a different home. Remember, A home directory on Garavalla is different to the home on Cetonix. So
if
it
you have
doesn't.
configurations done there,
Yeah,
you have to move it.
you have to copy the required files here, SCP or whatever. So yeah, it's not the same one. So we have to make sure, remember that one. And working data is a scratch. And well, let's go into each of these 4 file systems in detail. The first one is the working data, the scratch file system. So this is the file system where all your simulation data will be going into. So that means this is a temporary workspace. I'm not saying that semi-permanent or permanent workspace. It's a temporary, which longs for 21 days, unless until you find a ways around using it. Workspace were queued. That means the jobs that are currently queued, jobs that are currently running, and recently finished jobs. Don't let it go past the 3 weeks mark, the 21 days. So the current capacity is 9.8 petabytes. The first, actually, it is a fast parallel multi-user access of data. So that means multiple users can access. There are different OSTs. We're not going in depth into the terminology. So there are object storage targets, object storage service, OSS and OSTs. So in order to allow the multiple users trying to access this file system in a fast, efficient way, sometimes some of the OSTs will get filled up. So the 9.8 petabytes, there are around 100. I don't recall the number of OSTs at the moment. Sorry.
It's around 80, I think.
Okay. So all these 9.8 petabytes have been divided into these OSTs. And when you write a data, so it will pick up one of the OSTs unless until you decide the different targets. You can write, suppose if you're taking a 5 gig file, you can divide, okay, I don't want to write the 5 gig files into one of the OSTs, try to set striping. So you can set stripes, okay, don't do it on one OSTs, but try to divide these 5 gigs into 5 different OSTs. There is an important one. Currently, there is no default striping, it is set to 1. But you can change it. Is it?
No, there is a default striping.
Oh, okay.
So what happens when you create a directory or a file on Scratch? The system is configured to place. There is this policy that places parts of the file, different parts of the file. Depending on how big the file is, it may end up split across several disks. That's why if you see, there is a command where you can see the usage of each OST, which you can think of as a logical disk of the file system. You see the usage is quite fairly regular. Currently, I see each OST is around 60% full, but that's because each file that is created is split in chunks, and each chunk is placed on the list field OST. Which there is a policy such that the load is balanced across the across the storage devices.
So if you have say in simple language, what OST is?
Oh, sorry. So
I really don't quite.
Yeah. So it's on the logic. So on the logical level, OST is it's like a computer which has attached disks, like as attached storage devices, but it's seen as a logical disk. So on the system, OST you can see as a hard drive. It can be either a hard drive or a flash. So we have Scratch is divided, is partitioned in 2 sections. We have the flash partition, which is based on SSDs, essentially, storage SSDs, and then the other part, the biggest part is the spinning disks.
Right. So it's more like a temporary thing, resource that given access to for some certain purpose.
This OST is a way of organizing 2 or more drives together as a logical storage. So it's a storage device. You can see it as a storage device.
Yeah, the 9.8 petabyte file system is not just one drive. So it's divided into multiple hard drives, and multiple hard drives are treated as one OST. So when you write a big file, it goes into, it's not goes into the same hard drive, but it goes into multiple hard drives. So that's what we can.
And what we call a progressive file layout, or like it's a policy that decides how you distribute a big file over these multiple units. So basically, I think on Astro, what happened if you if you don't have such a policy, then what happens is the file system picks the disk which has the most amount of space, and you write the whole file there. But what happens is that there is not enough space there. You end up filling up the disk, right? And then what happens is you will have some disks that's completely full and other disks are completely empty, and it's not so good for performance. So what happens is you can set policy such that you can split files. You can split files on multiple disks, and this is done transparently to the user. So you're writing a file on the file system, but underneath the file system splits the file on multiple chunks. When you read back the files, the file system, the file system is basically another computing system that reads these multiple parts from device libraries and serves it to you as a single file.
So if I can go into my Scratch directory, one of the directories say student.
So the current policy, what it says is that the first part of the file, like the first, I think a few megabytes, I don't remember now, goes on the flash partition, means that its storage is stored on SSD disks. The reason is because despite the fact that we use big files, we have done a few statistics on Scratch, and the vast majority of files are not bigger than a few megabytes. So the vast majority, I think even close to 90% of files on Scratch are actually very small. The problem is, it's not with bigger. There are a few bigger files that few users write very big files, but many users write very small files, but many of them. And so we want them on the SSDs because they are small and they are faster to retrieve.
Sure.
But they are not, because they are small, they are not used the bandwidth. So they just cost a few megabytes. But then if you add them on disk, it takes time to bring them back. And it's just a waste of bandwidth in terms of the system. Whereas, and that's why we put them on flash. We just don't want to waste time to retrieve from disks. But then bigger files then have to go on disk also because the disk partition is bigger than the flash partition. SSDs are more expensive than streaming disks. Okay.
Yeah, that's right. I mean, so this is an important module, so that's why if you have any questions online as well, please raise your hand. So currently the file limit, the soft limit is 1 petabyte per project. So out of 9.8, you can access up to 1 petabyte per project and 1 million files per user. So per project, you can go up to 1 petabyte, that's a soft limit, and per user, 1 million. So what is this hard limit is like, suppose if you have reached the limit and your job is still running. So we do not want to stop it. So hard limit is that running job can go all the way up to 2 petabytes per project. And as a user, you can reach up to 2 million files per user. Once you reach the hard limit, even if your job is running, it will be terminated. So that's why the hard limit. Soft limit is you can submit the job if you are under that limit. And when your job is running and start generating the data, once you reach the hard limit, it will be cut off. So at the moment, 50% of the file system is filled up. Like out of 9.8, it's around 4.9 petabytes. inodes is well under limit, so it's only 1% of the inode, so which is a good thing. But things will change suddenly. We don't know. The limit is 1 million file per user. If you have a genuine case where you need to change it, please raise in a ticket. I'm just trying.
We can raise this ticket for special cases on a temporary basis. If you have a particular job that needs to write bigger files than and there's no other way around it, and for that particular case, we can make an exception. It's just that these limits are there to make sure that the file system stays active.
So I'm just trying to see the full screen, but it's going somewhere else. Okay. Now coming to the next one is be mindful of the 20-day. The best practice is the 21-day purge policy on Scratch. So please don't try to do the touch. Some users they do touch, but our admins have things in place. Can you add some? Okay, I can also. I admitted her. So Try to move the data to Acacia or whatever storage system, because some institutional storage, I believe you call. So try to move the data within the 21 days and delete the files which you don't need. Yeah, rather than letting the purge policy do those things. It's a good practice just to.
Yeah, I mean, it's certainly good practice. I completely understand the rationale from the system point of view. And of course, as Bradley also points out in our meetings, there are adjustments issues that many of us are going through. An interesting part about that makes it like a more difficult particularly for MWA users trying to process more recent data is, as you can imagine that, we had a reconfiguration even before that's a different array, and calibration issues are sometimes can be like dragging for some time. So say, for example, if I'm dealing with the VCS data, okay, so if I'm trying to process like a 1 hour or 1.5, well, that's like already 100 terabytes with the current bit depth and more receivers and things like that. So sometimes, that convergence of like getting through in a state that, oh, okay, I'm happy with the solutions. Let me just process it for beamforming. That process with when you have like other interruptions and other things as well, 21 days, is proving to be like quite a. I'm not saying that 30 days will make a big difference, but it's more like an issue to. If it was like something which deterministic way of like processing, it's not bad. But the kind of problems that we deal with, in some cases, it becomes like a really, okay, so I haven't completed my task, now I'm going to restart again. That's the kind of situation some of us are getting into. And so, yeah, I'm just saying it, so that you're aware that what is it coming from our side as well.
Yeah, it's a challenge.
It's a challenge.
Yeah, give it a try. And if you have got any things like, we have the Christian working with MWA people, raise it with him and he can bring it to our attention. Right, Christian? So, yeah. So the next one is Acacia object storage. Probably many of you already been using Acacia in order to store the project data. So this project data can stay for the entire life cycle of the project. I know the MWA projects, they don't have as allocation, yearly allocation, but yeah, they will stay until the PI decides, okay, I'm terminating the project. So it will be there. It is a high available object storage file system, so which we call as technically called, the term is called Ceph object storage. I think Kristen is going to talk about this one, the last module tomorrow, how to use Acacia. Which is again an important one, just to try to use it. By default, any merit allocation project will get 1 terabyte. Some of the projects and MWA projects are coming through the merit allocation, they get 1 terabyte. But if you want to go up to 110 terabyte, just the help desk ticket is enough, just with a small justification that we need it. But if you want to go beyond that, you need an application, so which is needed. This file system is different to the scratch, like traditional file systems like NFS or cluster file system. It has a different thing. Like, once the data is written to the object storage, it is read only. In order to modify it, you have to pull the data, change it, and then push the data. So it's a different way because it's for high availability, like, for really large storage. In order to access you need to have an S3 interface, such as currently we are using rclone and AWS CLI. So there was a previously menu client, but there were some issues we have noticed. That's why a small file system, it does work, but once you go to a certain limit, the menu client was failing. So try to stick to the rclone at the moment. So if it is, yeah.
One thing you can do actually is also reading directly the data streaming the data from Acacia to in memory in your application. If you write your program such that you can access this S3 interface, it's a protocol essentially. We can have command line programs that implement the protocol and can transfer data to the file system. But if you have a Python script or a Python program or a C++ program, you can write code or use libraries that can query Acacia and read data directly in memory. That's what I think you can
also do any kind of writing. Is that?
It should be, because you're implementing the S3 interface, and what the clients do essentially reading the file from the file system and then send it to Acacia. So I believe I haven't done it personally, but according to the documentation, and I know a few people, Danny Price, I think, experimented with that. So there are a few things you can do with Acacia. Of course, it requires some time, learning time, but
Yeah.
if you have data on Acacia, you have an observation, you want to directly read in memory, you can bypass the file system. If you have the whole process in memory, then you can actually speed up the computation quite a lot.
That's good. Yeah. Yeah, to know that. I thought like, normally some users, some other domains, what they do is they submit a different job to the data mover node, trying to pull the data from Acacia to this cluster and then start the job. And then after that, they submit another job to get the data. It's a workflow with like 3 different jobs.
Yeah.
But if you can directly read from Acacia, it's a sign.
Requires modification to the code, of course. But
Yeah.
So this is another software file system, which is primarily used to install, like, to user manage like Pawsey. As a Pawsey system-wide, we install system-wide packages in software in the same file system, and user managed software also will go into that one. So, and also you can use this file system to store some workflow basket or else the job script, not the input data, because the file limit is just only 256 gigabytes per project. It's a per project is 256 gigabytes and also 100,000 files per user. So it's very easy to hit that limit. So the main purpose of this file system is to allow the users to install install any software in their project directories. This is also a Lustre-based file system, just like a Scratch. So it has got the same features of a Lustre file system, but the only thing is it's pretty small. So at the moment, it's the Scratch file system is 9.8 petabytes, and software file system is just 2 terabytes. So, but it's both a Lustre-based file system. So, and that's why we put a limit on how much projects they can space. Each project can get up to
200 terabytes.
Yeah. 200 terabytes. Yeah. Oh, 200 terabytes. So, 2 terabytes is very small. Okay. Yeah, 200 terabytes. So that is 0.2 petabytes. It's organized in 3 levels, like project wide. If you want to use that one /software projects project ID, user level is just followed by the username, and my software, $my software. So, but be ensured that my software will pick up the default project ID. So if you want to use the other project ID, you have to make sure that it goes into the right place. Use the absolute path. Whatever the data that is in this file system is available for the lifetime of the project. The next one is the home file system, which is the old traditional file system of NFS. It is a network file system, which is not at all designed for performance. So please do not run any jobs keeping your input data from here, or even the binaries, like, whenever you run the jobs, like, it's very slow. It's a orders of magnitudes of difference. So the main purpose of this file system is to just to store the configuration files such as bash RC or the Acacia access keys or whatever SSH keys, but not for any other purpose. Like, any private data should stay here. It has got only 1 gigabyte GB per user and 10,000 files per user. So it is pretty small. So try to avoid it using for other purposes. And you can access this one directly with the till symbol or the $home environment variable. So again, this home is different to the home which you're currently having on Garavala. So if you want to have all those files in Garavala, so you need to copy them to don't try to copy everything, try to see what is needed and then copy across. Otherwise, it's and one thing we have noticed over the years is that people try to put the workflow related settings in the bash RC. Don't load this module. So by default, they will load hundreds of modules in the bash RC. And when they request help from the Pawsey, like to help desk, we don't see those bash RC, and we do not have permission to see your home directory. Home directory is a private data. So unless you authorize us, it doesn't really work out. It's a long process. So try to avoid putting all the module loads or other settings in the bash RC.
It makes the workflow so not reproducible. If you have everything on your submit job, then you can reproduce what's happening.
So we have seen some users projects, they share the bash RC across the project. You copy everything in the bash RC, and then that's fine. within the project, if you're doing, it's your risk. But when if you ask any help from the Pawsey or any other project, they won't be able to reproduce the problem, and it takes really long to. So the best thing is always put those workflow related settings in the job script so that we can able to see that.
Yeah, these are all like some leftover traditions, when you have like some new user, you will say, okay, everything is set up in my bash RC, you just do it. But
so in order to monitor, because now we have seen the file limits and the file sizes, so just to see quickly, in order to see the home space, there is a command called quota -s. So -s is the command, quota -s. If you have, that will show you the space. And there used to be a script called Pawsey. Yeah, of course, many of you might have used the Pawsey account balance. If you use this flag -s, -s stands for storage. Currently, this particular option is broken. And while we are discussing, there is another meeting happening in parallel. They are discussing on this issue. I raised the ticket again. So it will be fixed up soon. So currently it is pointing the storage of Astro and other file system, which has been decommissioned. So in the meantime, there is another command called myquota.new. So this shows the everything in one place. So it's a really handy tool. So myquota.new. I'm not sure whether it is enabled on Caravana, but on Cetonix, it will show what is your home file system looks like and how many files and what's the quota limits for software. And if you're part of multiple projects, it will show everything. And if you are tech savvy, you can rely on this LFS quota on Lustre commands. Sometimes I keep getting it wrong. So yeah, but
I get it wrong all the time because it's different to the quota command.
that's LFS quota. Yeah, that's right. LFS quota. It is for the Lustre file systems, which is Scratch and software file system.
And the Petrichor system as well. CSR has a custom quota command that's the same. It has the same -s flag.
Oh, okay.
But because the two flags are different between LFS quota and you get confused.
Both. That's right. Yeah, because normally as stands for storage, we typically go there. But it's a best practice, one of the best practice, always monitor your file limit. And if there is anything, try to remove the files that are unwanted and try to use other ways. Yeah, try to avoid hitting the file limit. Because when your job is running and if you on the last minute of your job and then if it hits doesn't make any, because you have to wait for one more day for your data to generate. So just the description. So quota -s, this is for the home file systems. So you can see that there is 1 GB, that is 1024 MB, and then 10,000 file is the quota. So try to, I think my colleague who created this slide is very good. So he's got only the configuration file. So that one, And then Pawsey account balance -s, currently it's broken, as I said. So you should display the last part, the storage information along with your allocation. Try to see, you can see that for Scratch, it's 2048 TIB, which is the petabytes, so 2 petabytes. That is the hard limit it is showing. It is not the soft limit. So you can go all the way up there, but once you cross the 1 petabyte, you won't be able to submit your jobs. Likewise for the software usage, software, which is 256 gigabytes. It doesn't show the number of files. That's why I'm encouraging to use the command called myquota.new.
Okay.
Which it has got. Anyone ran that command?
Yeah, I did. I mean, of course, I don't know.
Yeah, it has got everything. So you can see for the home software, Scratch, everything in one place. I currently haven't got that one. So yesterday only I spoke to Chris and got an approval. Can I use it? Because it's been there for a while, but
it's quite busy if you're part of a lot of projects.
Yeah, that's what. Because we, as a helped, working on user tickets, we add to the projects, and then we can see how the users are doing with the files. Otherwise, you can use this LFS quota commands -h. -g is that is the group. G stands for group. -u stands for user. So you can see as a sorry, the mouse is a bit slower. Okay. So for the Scratch, as a project wide, you have got 1 petabyte soft limit. As a user, you got 1 million file limit. So these are the main things you need to keep looking. So once you hit the limit, there will be a star next to that. So the files, if you hit that 1 million, there will be a star next to that. And then software, Again, the space is important here, 256 gigabytes. And again, as a user, again, the limit is the 100,000. So you can check, but my quota.new will show in everything in one place. So to summarize, in this module, we have learned a brief description of file system and different ways to monitor. Try to avoid using home file system to keep your important stuff. Just use it for the private data, and try to use the workflow related in your job scripts. And always remember the 21-day purge policy, and proactive, like, don't let hit the limit and then try to delete the data, but you can have the best practice. So this is the documentation, everything. Question on session. Anyone wants a break? It's now 10:20.
If yeah, depending if you want to read now, but at 11 a.m. we also have some tea, I think.
Yeah, there is a, but you can have a tea now, but
Yeah.
biscuits will come at 11, so that won't be.
So if you want to have a break now, it's.
What about the online participant? Any questions? I went a bit slower for this module, but as we go, it will be really. Okay, so let's take 10-minute break.
Yeah.
Let's see at 10:30. It's now 10:22.
Yeah.
10:30.
Yeah.
Yes. Stop the recording. Let it continue.
No, it's fine. Then they will cut to some editing.
Maybe you can pour the coffee.
Yeah.
Yeah. If any questions, maybe put in the chat window, or otherwise, yeah, we'll see in 10 minutes.
Yes. They like to. It's a nice one.
Very nice.
This is
a very beautiful. White and nice. I come to.
Like this column.
Very well done. Thanks for correcting the cache.
Then what comes to the So we're going to see another 3 more modules today, and then we'll go to the 2. Yeah, 3 more modules.
3 more modules.
3 more modules, and then tomorrow we'll see the remaining 5. I know that most of the users are experienced users, like from Garawa, so you know everything. But if there is anything, if you want to learn, please. One thing that I remember about because the whole file system is just only 1 gigabyte per user. So, and the .cache file, normally when you install any software, it goes and sits in the .cache file, which is in the home directory, which gets filled up. And people normally get the disk quota exceeded error. So in order to avoid that one, what you can do is you can create a directory in your Scratch .cache and symlink that one there, like symlink the .cache to the home cache file, so that when you install anything, that will go to the Scratch file system, which we have 1 million.
Oh, should be depending whether you want to retain that or not.
Yeah, that's what
you
normally
can symlink either to
software
or Scratch.
Yeah, normally the cache files, it's just the temporary, which I never got any chance. But if you get, I think the Rust installation also have a .cargo file which goes into the home. Christian, I think it was software or Scratch.
That depending on the use case, but
Yeah.
there is this trick of symlinking some directories, to the other file systems.
Yeah.
Because of some software are designed to just write everything on their home, assuming it's like a personal laptop and you have enough space to store data and cache.
Yeah.
But on Cetonix, we suggest using links to software for depending on the content of the directory. For instance, some editors like Visual Studio Code stores permanent as well cache the same directory, so that I symlink on software, but then I oftentimes also delete the content myself. So there is some upkeeping you have to do with the home directory, but you will notice because depending whether you have a link or not, you can hit the quota, and then you know that there is some cache file you need to delete.
So what you are suggesting, make a symbolic link to or the
.cache
.cache from
Depending on depending on the programs you use. For instance, in my case, I use the Visual Studio Code Editor.
Right.
It's an editor creates some files. The home directory can be, sometimes the cache files can be quite heavy. So
you have to see your program dependent, because if you write something to the Scratch, it's only for there for 21 days. And if you want it for longer, so my software. So that's where you have to write it there. And so if you come across any situations like that, like I'm going to say, you've been using on Garawala the same 1 gigabyte, 1 GB per user and everything, but try to, there are on Cetonix, the Nextflow and Singularity, all those cache directories are already pointed to this my software. So you won't see them in your home directory, but in and even the Python installation goes to my software because it writes some hidden files. So in order to help the user, so we do that one. So don't look into the home directory for those hidden files, but try to see in the my software as well. Okay, coming to the fourth module, so moving data in and out of Pawsey. It's pretty much like, there are lots of data coming in, so how we can use it. So the fourth module, some of the signs. So in order to help the users to move the data, so I mean, MWA users have already using this copy partition, I believe, on Garawala, so it's pretty much the same thing. So we provided these data mover nodes, which are these are externally connected high bandwidth nodes in order to facilitate the large amounts of data transfer between the high performance system. That means between the, like suppose if you want to copy 1 terabyte data from Scratch to software, don't just run CP command, but use the data mover nodes. These are high bandwidth, so they do a lot of good efficient for memory transfers. So always try to, if you're maybe even for small data transfer, if you try to use the data mover nodes, it's a good practice. So that's one of the good practice. So but normally, traditionally, we just quickly use the login nodes, but we don't know because sometimes
depending on the file size and the length of the transfers. Few megabytes or even 1 gigabyte, it would take a few minutes on a login node, it's okay. But if you have one file, but if you have like terabytes of data and many files, that can disrupt the login node. So it always practice to use the data mover nodes.
Data mover nodes. If that means notice that someone is doing a load copy, there you will either get an email, or if it is real affecting the login node, it just get terminated. So that means your data is halfway. If you are running a move command, that means you might lose the data. So better use the data mover nodes. Does it make sense? Like, if the login nodes are really getting affected because of your copy, they might just terminate. Or if the login nodes disappears, I mean, say if someone is doing bad things on login node and your copy command is sitting there, and for some reason login nodes dies, your copy also dies. So
this applies for things like rsync.
Yes. rsync, SCP, and everything.
All right. I think that's one of the things I do running rsync. Say, for example, to bring the data from the other telescopes, not MWA, like EMRT, which we routinely use, or parts, where these days, typically, even their backend data could be like hundreds of gigabytes, or typical files can be like tens of gigabytes easily. And I have been doing it with maybe like you can complete, then I will ask you later, what is the best way to do it.
Okay. So, and these data mover nodes are connected to all Pawsey global storage locations. It's connected to Acacia. It's connected to all different tape storage systems. It enables transfers, and it's basically to use for large data transfers and without overloading the login node. So please don't. And two terms which we need to note here is the data staging and data archiving. Data staging is basically getting the copy data from your laptop or some other institutional servers to Pawsey. That is called pushing. And data archiving at Pawsey is basically taking the data out of Pawsey servers to the work, which is pulling. So these two things. For both these things, the best practice to use the data mover nodes to both stage and to archive data. So always never try to copy. Of course, if it's a really small 1 megabyte file, maybe it's fine, but it's a good habit to use these data mover nodes for any transfer so that by mistakenly you won't be using the login nodes for the large data transfers, which might affect in the future. So yeah, from the world to the Pawsey and Pawsey to the thing. Data access to these data mover nodes. Probably might have seen this slide in the previous training sessions. So Pawsey firewalls allow both incoming and outgoing SSH connections. So you can connect from anywhere. So some of the curtain your incoming SSH connections has been blocked, like unless until you are in the proper access. So whereas these nodes you can access from anywhere, so you won't get blocked. So, and also you can access these data mover nodes via the copy partition. I remember we have created a ASO copy partition for astronomy,
Yes.
MWA, some copy that there's a two nodes on that one.
That's depending on the use case. I think those are reserved for ASO operations.
ASO operations.
But the other copy queues are available
For general purpose, yeah. So if you are not part of this ASO operations, then you won't be able to access them. So it's only coming to that one. So how do you transfer backend code? So we can do a demo, but normally it's pretty straightforward. So the recommended command line tools are SCP and rsync. So rsync is really handy. So it goes incremental style, whereas SCP, it's all a black box. So we don't know how it goes. And graphical user interface tools are also available, such as MobileXtem, FileZilla. So, but you need to be very extremely careful with this graphical user interface because there is an auto retry option in MobileXtem, I believe. So, which if you enter your incorrect password, it tries to retry again and again, and then eventually your IP will get blacklisted. So try to disable that login auto retry so that you won't get blacklisted. So if you're using these graphical user interface tools. And if you're transferring large number of files, like minimum, it's a good habit, good practice to tar them into a single tar file. So maybe not like thousands in one tar file. You can decide like what is the appropriate way, like into tar, like how many number of files into. Yeah, at the moment we are working on millions of files, not like for every 100 means there will be another 1,000 tar bars, not like that, but you can have a look like maybe 1,000 or 2,000 files into one tar file, so that if you transfer individual files, it's going to take really longer. Whereas if you go as a single tar file, it's really effective. And some of the demo we can, if you're interested, maybe you can run later in the day this demo, and if you have any problems, we can, because these are pretty basic exercises. So what we are trying to do is on my laptop, I'm doing an echo command hello from local, that is local laptop, and I'm diverting it to my file. I'm creating a file which is copied into this my file. Then I'm copying this SCP my file to the using the data mover nodes to my Scratch file system. This is a single file. But if you're copying hundreds of files, tar them. Yeah, that's a thing. In order to see whether you have got the file into this one, now you need to log into Cetonix, go to the Scratch directory. You can have a look, ls Scratch project ID username. So this project ID is unique for each person. Username is your personal username, and you should be able to see my file. And then you can exit. And then now if you say, okay, I want that file which is sitting on Cetonix, Scratch file system, back as a different file name. This is called file is back. So you can create that one, and when you do ls, so you can see two files. Initially, there you created a file called my file. Now it became the my file and file is back. So you can copy data staging and data archiving. So the first part is data staging, where you copy the data, and data archiving is bringing the data out of there. So here is the staging data exercise, pretty much the same thing which I've shown. Here I'm creating 3 files. Because of the lack of time, we are not running the exercises, but let me know if anyone wants me to do it live, then I can do it. Anyone wants me to do it live or? the exercises, like you
Not
can try.
yet, but I have a question. So I think going back to my earlier one, so
Yeah.
these days observatories like GMRT, they give you like an option because earlier they used to have like the gateway servers where some PIs will be given like an account to access and somebody else there will state the data for you. But these days data are so big, so they are just giving you like either a web link or like a wget kind of an option.
Okay.
So when I have those things, which is working out quite efficiently, and do I do it from a data mover or do I, what is the best way?
I would suggest at that point to submit this download as a job.
Yeah,
So you have, we have the copy partition. So these data mover nodes, you can use them as a login node interactively, but you can also submit jobs like Slam to Slam in the copy partition. And
Yeah, you can decide how much time, like, if you have a rough idea how much time it takes, you create a job script and then do the copy partition and submit as a job, and then have it the run command wget
yeah,
the data, so that everything happens in the background. So
So-
if you do it on the login node,
yeah,
and if due to inactivity,
Yeah.
if your shell
yeah.
terminates,
Yeah.
then you lose the data.
Sure.
Everything you have to
Yeah.
start.
Yeah.
So submitting as a job script is the best
Okay.
idea
Right, okay.
to the copy partition.
so the copy partition has a time limit of 2 days. So it's not only 24 hours, 2 days. So you have 2 days to download the data. And it's good because you have reserved resources to do that, just like a job. If you do it as an interactive as on the head nodes, then you have to resource contention with other people. But if when you do submit it as a job, like compute nodes, you have reserved resources to do the copy. So usually it could be faster.
Yeah,
And so when you log into the data movement node, that's not the same as being a hot login node.
Yeah,
or
it's a
something.
different.
So you can still do all the work, the copying, the editing work. from
When you copy SSH into a copy node, like a data mover node, you're gone into one of the copy partition nodes. Like it can be DM1, like data mover one. It can be any one. So it goes. But as Christian has said, like if you submit as a job, the Slurm will allocate the resources for your job throughout the session. But if you submit on the login node and suddenly someone else comes onto the login node and try to do things, there are no set resources, and then your copy partition, your copy or pulling the data might see a difference in performance.
correct.
Whereas that one is a standard,
Yes.
keeps on going.
So basically the wget or those sort of things, just if it is like a large file transfer, submit that as a job.
So
Yes.
yes, to the copy partition.
Yeah, yeah, sure.
So here in this exercise, we are basically creating 3 files, echo file number 1, file 1, file 3. So now we are not transferring them as individual files, but we are transferring them as a tar file. So the second part is basically showing the tar command in order to compress the file. So that finally the regular expression file question marks, that means whatever the number comes after that, it just picks it up like whatever the extension. And then basically you can use the SCP command and you can transfer it as one tar file rather than 3 different files. That is exercise. So it's pretty basic one. You can run them later in the day, and if you have any questions tomorrow, we can go through that one. Okay. And then this is the same thing, how it happened. Yeah, here we are using SCP and SSH into the login into the system. Again, another exercise is the archiving data. That means try to get the data from scratch out to your local machine. So it's how it works. So data transfers using the copy partition. So far, we have mentioned about how to use them using the login node. But yeah, when you do SSH, this one SSH, you are on the login node, but we are not SSHing into this data mover node, but we are using the data mover nodes to do the copy.
Now, correct me if I'm wrong. I think now Garavarla, the data mover nodes on Garavarla, are they still there? Or?
They're still there,
Okay.
I think.
Yeah, no, it's okay.
Not sure whether they are used. Okay, maybe.
What is that?
On Garavarla, is the copy partition still available, or we can have a check? Yeah.
You mean the
I just want to think about differences on the copy partition between Garavarla and Sectronics. I think
It's pretty much the same. I think it's just a different nodes.
yeah.
It's a different node, so it's not the same one. So in order to transfer, like, when you said wget as a large transfer, you can use the copy partition, just submit as a job rather than remotely from your computer. So yeah, interactive session sometimes will break. So this one is especially the copy partition useful if you want to copy data from scratch to Acacia rather than using the login node. If you want to copy the copy partition, submit as a job. Okay, copy all the data that is in my scratch to Acacia.
Also, they are not on the copy partition. I just checked; they are not built to the job. It's the copy job is not built.
Not built.
It's not it doesn't account.
Oh, it's not accounted for your.
So don't copy data, big large transfers using your compute allocation. The copy partition is not built, so it's just dedicated for copies.
So you won't be charged for the
You won't
copy
be charged
transfer.
for the copy.
Yeah.
It's a free resource,
Okay.
just to copy data across,
Yeah.
to encourage people to move the data out of Pawsey file systems and try to encourage them. So I did notice that, yeah. So, and also, this is not good for copying the copy partition. You won't be able to copy data from Pawsey file systems to your local laptop, but you can able to, like, if institutional servers, like, storage systems or AWS storage, you can able to use this copy partition, try to copy from Acacia or Scratch to your institutional data. So it's not to the laptops yet.
But the reason is from a job initiating a copy, it has to be a public IP.
Public IP, okay.
So if you want to connect to a server from your job, then you have to have a public, and something that is actively listening, but your laptop is not actively it's not
listening.
reachable from outside. You can reach out, but you cannot reach in. So usually this, if you want to copy something to your laptop, you have to initiate the copy on your laptop and then using the data mover nodes not as just as a normal server, not through a job.
Yeah, so in order to use this one, the scheduler option is minus partition equal to copy. So that's why you can use these ones. So always it's a good interactive session is good for small, quick data transfers, but whereas if it is a large data transfer, going the bash script. Bash script is basically the job runs in the background, handled by the slum. So you don't see everything. Again, the best practice, always pack files. Pack them.
So when you say small and large, so what could be a large, like in terms of gigabytes or terabytes or?
We don't have a set policy on that,
Yeah.
but I think if it takes more than an hour, we suggest to.
Sure.
Okay.
We suggest to just submit as a job. Because there is the risk of interruption, the risk of losing the time. You spend copying, then you have to start again. In some cases.
Yeah, you can see the time. Like, if it is small, like maybe 5 to 10 minutes, that's fine.
Yeah.
If it's
Like
more than
yesterday.
that,
Also in terms of how much memory you're going to consume on the node.
no.
Yeah.
So I regularly use the data movement the login part of the data movement node to download measurement sets from ASVO. But it's one by one, so it's kind of download one, the 8 gigabyte data set, then download the next one dependent. Would it be better to have that script? Would that make a huge difference for that one? They're all independent. So
I think the job script gives you the assurance that you have dedicated resources and you can run it for that amount of time, and that on the MWA interactively it's more for you just if it gets interrupted for some reason, then but if you're downloading one by one, it's fine.
Please always note, like sometimes say 200 gig files, for example, sometimes it might take 5 minutes to copy across, but maybe another time 10 minutes. So yeah, it depends on the bandwidth available across. So as part of this module, we learned about data staging, archiving, SCP commands, and how we can use this one. So yeah, go through the exercises, and if you have any questions, please bring it for tomorrow. We'll move to the next one. It's 11 o'clock, so it's a good time to go for the next one.
Okay.
Sorry, I haven't some.
I can share my laptop now. Okay. The fifth module is about the software, how to use software on Cetonix and the software stack. This is, I think, one of the biggest change you find from going from Garola to Cetonix, apart from the fact that now the system is an AMD-based system. The biggest change is about the GPU architecture. That is what we faced, what everybody has faced first. But another change is the way you have the software available, the way you can install your own software, and the software that is provided by Pawsey, all the policies around this. On Garavalla, you have on Garavalla, you have the possibility of installing your software. To my understanding, there is not a very well-defined agreement on who installs software on Garavalla, because Garavalla is technically an MWA system, and the software is, we run it on the hardware level, but the software, the way it's configured, is based on the requirements that MWA does. Pawsey, we want to do things this way. So now, I know a lot of people, I think Sammy and Bradley and a few other people install software for everybody under the Pawsey file system. There is still this Pawsey file system available on Garavalla, which is not available on Cetonix. Currently, your software is under Pawsey/MWA something else, and that is the allocation where the software is available to all groups, and it's installed by researchers, and they coordinate, MWA researchers coordinate themselves and they install software. Sometimes they ask for help to Pawsey to install some software such as Singularity or any other debugger compilers, but there is not really a policy on who is installing this software. Actually, the software stack on Garavalla has been updated or changed in quite a long time. We update the operative system from time to time because of security updates. That's what we do. We keep the system safe. But in terms of compilers and libraries provided there, it's pretty much up to MWA researchers. And whereas on Pawsey, we provide not only the compute infrastructure, but also the software, a set of software libraries and applications to all users. And we do it in a way we compile the software to be executed efficiently on Cetonix, so optimized for the architecture. And we also provide regular updates to the stack such that every 6 months or every year, every allocation round, users have access to the latest versions of popular software. So we provide libraries, numerical libraries, for instance. We provide OpenBlast, which is a linear algebra library. We provide I/O libraries such as HDF5 and NetCDF and a few a wide variety of numerical I/O libraries that can be used by all users. We call this software stack system-wide because it's installed in a location accessible to all users, read-only, and it's managed by Pawsey staff. Every 6 months or 1 year, we update with the latest versions. That's what we call the system-wide software stack. So a software stack essentially is a collection of software packages and the dependencies. We provide software not only for MWA, but for all researchers, for all software, I would say, for all major scientific domains. Each scientific domain has a very popular application that is being used, and so makes no sense for each group to install the same application. In such case, we have these applications. We manage the installation and provide the updates and make sure that it's configured to run optimally on Cetonix. We do have in total, we install 500 packages, that is including dependencies. So it's quite a large number of packages to install and maintain. And we take on that beauty so that users don't have to do the same themselves, and they have an environment that is ready to run the most popular applications. Of course, we cannot cover all this system-wide software is installed under this path, software Setonics. And every time we deploy a new software stack, we version it with the year and month has been deployed. So you can actually have multiple versions at the same time on the system, and you can choose which version of the stack to use. And sometimes you have the choice, other times you remove the older one because it won't work anymore on the system because the underlying operating system might have been updated. So depending on the use case, you may have multiple software stack deployed on the system. And we cannot, of course, provide and maintain all the possible applications users can use. We just make a survey if a group asks, this application has been used by 3 or 4 more groups, then it means that it's popular and we provide that. Also to avoid duplications, having the same files multiple times. An important also thing is that not only the application itself, but also the dependencies are installed. And that avoids the user to install many files. But of course, you may also find yourself, you need to install your own software, perhaps the one you are developing yourself, or software that is peculiar to your group. And then we also provide locations to install software that is accessible to all members of a project. So in this case, it will be located under this tree, or it can be personal to you, to your user, and then we provide this other location. So there are what we say we have 3 levels of the software stack: system-wide, project-wide, and user private.
Just an update to what Christina said, not 500 packages, but close to 1,700 packages overall.
Okay.
Yeah, with spec.
Well, because of
all the dependencies and everything.
So this is what we manage the system-wide installation. Users have the duty, or it's up to them to install their own packages under their own project and user directories. We provide documentation and also facilities to install software and to make it easy for you. But technically, we provide the best effort support for your own software, but it's up to the user to make sure it works and it's compiled. We provide help, but what we guarantee is that we manage to optimize what we provide system-wide. In addition to another difference with respect to Terravarla is that Setonics is an HP Cray system. An HP Cray system, when you acquire such a system, it comes not only the hardware, but also a software environment itself. So the Pawsey environment is built on top of what is called the Cray programming environment. So Cray programming environment is essentially defined by a compiler suite and related libraries that have been compiled, and we got compiler. It's as a high-level description. You may be aware that there are different compilers available for you to compile your software. So the most popular is, GCC. And that is provided as a programming environment based on GCC, and that is the default programming environment on Setonics. But we also have the Cray proprietary compiler. So you could compile your software with GCC or the Cray compiler, and each of these environments, depending on the as libraries, some libraries, numerical libraries that are compiled with a particular compiler. And you can, depending on the application, some compilers are better and produce better code for application, but worse code for another. So they can depend on use cases. For instance, Igor really likes to use the Cray environment because it's Fortran code. The Fortran compiler of the Cray compiler is better than the GCC apparently, but in general, we found that for C++ software, we find that the GCC compiler was doing a better job. So the software stack we provide a software stack based on GCC and a subset of the stack with the Cray compiler. What you see by default login on Setonics is what we compile with GCC. Let's see. Now, we install software using this packet manager, and this is also another big change from Terravarla. Terravarla software, you install software using scripts. Every time you install the software, you need to write a script, build scripts called simake, and do install the software if you have your own software. Pawsey staff used to install software using this Mali tool, which automated some parts of the process. So we write these kind of recipes to build software, then the money tool would run this recipe, would run the recipe to install the software stack. It builds on top of that is that idea, but what it does also manages dependencies. For instance, if you install, let's just from an example, you can install WScreen, and when you install WScreen, it checks whether the dependencies are there and whether it has to install also the dependencies. So what happens is it's in the package manager install a software and install and all its dependencies. If the dependencies are already there, they are going to be reused, so they don't need to install them again. That will avoid, installing duplicate installations, but also it does more than that. It also allows you to specify which version of the software to install, which option of the compilation to activate. For instance, we want to compile it with IDG or without IDG, so the stack allows you great flexibility to in deciding what you want to install. You give it a specification what you want to install, and then it takes care of downloading the packages and compiling the way you want. And we use Spark to install the system-wide software stack, so the stack provided by Pawsey. It allows them to install all those packages in 1 day or less than a day, whereas before Spark it would take weeks, and it takes so much time, and there were errors that they used to debug. But now we have managed to deploy software stack with updated version in a very automated way. It takes less than a day. But the same Spark instance or package manager can also be accessed by users to install software in their project or private directories. So, and Spark, covers around at this point 8,000 packages. So it has recipes, which are basically instructions on how to install the software. So and it's used by all the major supercomputing centers in the world, or most of the supercomputing centers in the world, so that there is a global effort to support many software such that people don't have to write build scripts every time, and you can just with one command install the software. So that's the great convenience of using this package manager. We also support containers using Singularity, pretty much just like Caravalla. On Cetonix, we do have a wide variety of Singularity modules. They differ mainly on the directories that are visible within the container. So we have modules specifically targeting NASCAR. We have general modules in targeting NPI applications. Depending on your use case, you may want to use a different module. And the difference is basically on the directories that are visible within the container. Python for Spark is good for compiled software, so C, C++, Fortran codes. You can also install Python packages, but we recommend to use pip or to install Python packages. That is more suitable for those type of applications, and we configure the Python installations to install the Python packages not in your home directory, but in the software /software path. So what it means now is that MWA people, you would have to, if you want to install software, you can. It will be limited to your project or your user. But what happens is if you have many groups using, for instance, WScreen, you can request to have that part of the system-wide installation. That is actually what I've been working with them. We have a set of packages installed system-wide, and WScreen is one of them. So WScreen now is installed for all the users. You don't have to install it, it's there, and it's maintained by us. So we make sure that we install it every time we deploy the software stack, make sure it's optimized and working. If you have any issues, you can open the ticket and we try to fix it because it's supported. And not only WScreen itself, but also the dependencies, so AO Flagger and HDF5. So you don't have to go and find those dependencies yourself. It's all there. And if you want a different version, you can install. That doesn't mean you can the same software package. You can install it again locally if you want a different configuration. But Spark will also manage to reuse the dependencies already installed system-wide, so you don't have to install all the dependencies back again.
Yeah, but one thing to remember, if anyone asks to install a system wide, we can install only during the maintenance window time.
Yes.
Once in a month, or it has to go through the change request because we are updating the system.
So if the
status.
process to modify the system software stack there's a process. It's takes some time, but eventually it gets there.
It get installed. So if you're in an urgent need, yeah, you have to install it local wide or project wide. And once it gets installed system wide, you can delete them and then you can use the system one.
Just like Caravana, once you install the software with Spark, it's made available through modules. So as a user, you see the software as a module, just like Caravana. So you have the module command. The module command to which is based on Lmod. Lmod, I think, is the same as Caravana. Caravana's Lmod. And the module command will show you this is the list of the modules that are available at login time, I believe. So what you see here is that you see quite a few modules, more than what you see on Caravana when you load. This is because we have a Cray related software. So for instance, you see the programming environment is blue. So and then the compiler is GCC. So this is what you have available by default. Then you have a few libraries here. Cray and Peach is the MPI implementation of Cray. So it's not OpenMPI, it's Cray and Peach. So that's another change. They should be API compatible with OpenMPI for most.
I think OpenMPI is not API. It's still not. Intel MPI is API.
No, API. I mean API.
Oh,
the API should be the same.
API.
So your code should mostly compile.
Yeah. Okay.
If you have OpenMPI or Cray, but you need to recompile your software. Then you have this Cray libc, which also libc, which implements
math libraries.
Yeah,
Glass,
LAPACK, and mathematical operations by Cray, so it's optimized by Cray. And so OCM this module is basically what makes you the software stack available, the Pawsey software stack available. So you see it's being versioned by the year and month that the last software stack has been deployed. So it was May this year.
Yeah, we aim to provide once in 6 months, but sometimes like for the stability, we continue once we find a proper one. It depends on how the Cray is providing their updates.
So as you can, I already spoke about the programming environments already. We have a few CPU architecture specific optimizations that are these modules are particularly useful when you use the Cray compiler wrappers. But so what happens when you use the GCC available here? GCC that you see here available as a module is not the pure GCC installation, but it's a, let's say, a customization made by Cray. And when you compile your code and you use you can use directly the GCC command, or you can use the Cray compiler wrappers. These Cray compiler wrappers allows you to they are useful and helps you with integrating the compilations of various Cray libraries such as the MPI. So when you use these compiler wrappers that are basically the CC and help.cc as defined by Cray, they will automatically find all these optimizations based on the CPU architecture. We find the MPI we need, and etc. This is all documented in our documentation, but it's another difference compared to what you have on Caravana.
Just like going back to Magnus days. Magnus has got Cray wrapper, so if you have used Magnus, which probably you might have that one. Yeah, normally with GCC, when you use that, you will have the G Fortran, G++, but it's basically on HPE Cray system. You have to use the Cray wrapper, CC, capital CC, and
the module command can use to browse available modules. Just like on Garawala, you have the module available. For instance, this is the computational chemistry package. You can look for packages just like that, and pretty same as Garawala. You can see now that the software is located, the module at least is located under this path. So you see that it's under the 2024.5 deployment. It's compiled with GCC 12, and then it's under the category application. So when you browse the module, you see we divided the modules for ease of use and access in various categories. So applications, programming programming languages, containers, and few other categories there, numerical libraries, so that you can browse and see what is available on the system. There is also, in particular for you, there is this Astro applications category where you have W screen. We have installed Hyperdrive, Hyper-V, few other packages used by multiple groups. So it's already there for you to be used. No need to install it yourself. We have different programming environments. We don't have one. The default one is GCC, and most probably the GNU programming environment, which has the GCC compiler. Most probably you will be using this one because it's loaded by default, and most users use that environment, so they don't really worry about swapping environments. But if you want to try a different compiler, the Cray compiler, you can swap to this programming environment and then compile the software with that. But because it's a different compiler, it will be a different software stack. So what you compile with GCC won't be available or visible when you use the Cray environment, and vice versa. This is because to keep things clean and reliable, we don't usually allow cross compilation or like compiling with different compilers. Complete the same application, but mixing the compilation, mixing the use of software compiled with different compilers, essentially. Another difference with Garawala is that now we enforce the use of a version when you load the module. So you cannot simply just do module load W screen. You have to specify the version you want to load. And that is to help us, when you submit a ticket, to help us understand what module you use and to make it more reproducible. There is a way you could use module load W screen, for instance, /default, and that will load the default version. But that is a workaround that you could use that and then use it, but we don't support that, and it's not recommended. That's because we don't actively set defaults when we deploy the software stack, and you may load a different module, a different version, and you wouldn't realize that. So that's very dangerous practice to do. And so always specify the versions of the software you use. That has the disadvantage of sometimes when we deploy the new software stack, you might have to update the scripts, but that is a price to pay for having a reproducible script and you know what you're actually executing. We have a few examples on what happens when you load a module. So when you load a module, you will see that it's actually in the list of loaded modules here. You see the path of where that module has been installed. Always under software settings 2024.05. Any questions so far? Okay. We have a few exercises here. That is the error that comes up when you try to load a module without the version. It says default module versions are disabled by your system administrator. So you have to specify the version just like this.
Yeah, just for the reproducibility purpose, because on Garawala you can load just by the module name, but here on Cetonix you need to specify the version as well, so that whenever we update the versions, it's a good practice just to keep them, update them as well.
Yeah, so my current workflow, if I'm like in interactive mode, often I will just module load the name, and then when it tells me what version to use, I then copy and paste that one in. Because it's about the same amount of time as module veil thing.
Oh, you can actually use also tab completion.
Yeah, just module.
Double tab and
That's so
then
much easier.
that will tell you what
What is that command?
So what I'm saying is that and this just let me show you.
That's so much easier. Thank you.
So basically, we should just start keeping track of the version that we are
Versions,
using.
because
for
we keep
practicing.
updating the versions.
So for instance, what happens is, and now on Setonis, if I want to load WS Clean, let's say module, load WS, WS Clean, what happens is, says, okay, you cannot do that. Please load modules.
Yeah,
in
I saw
version.
that.
So now if you hit tab twice,
Uh-huh.
it tells you what versions you have available.
What options?
What options?
Interesting, because here we've got singularity that completes to these ones, but then comes up with this one. So,
Because there is a singularity in that one.
So, 1 second, let me finish this example.
yeah,
So,
sorry.
so for instance, let's say I want to load the version 3.4, and you see also in the version, sometimes we add some features. So if we want to make users know that version of WSCreen has been compiled with IDG and everything, we just add it in the version tag. So now that I do tab completion, just I didn't have to type anything, I can just load it, and then I can just simply run down the screen just like that, and you see that this prints that message.
Right.
Okay. This is somehow an advanced topic, so module hierarchies. Modules are organized in hierarchies based on the compiler used to compile the software, the architecture you have on the system, and that's also another difference actually that is with Setonis. Almost all nodes on Setonis have a Zen3 CPU architecture. That means the AMD Milan architecture, CPU architecture, but the copy queue is based on the previous generation of the CPU, so it's Zen2. And that why is that is important in practice? It's important because it's part of the path you have where the software is installed. So Zen3 is the code name for the Milan CPU architecture, it's an architecture which has some optimizations. So we compile the software based on that architecture. But if you for copy nodes, some software we store the software also for the copy partition. Because you need to, for instance, clone to copy data. So you want to have it compiled for that architecture, and you want to also have other software that is available for copy operation. But that has to be, because the architecture is part of the hierarchy, what happens is that you cannot mix Zen 2 and Zen 3 codes together because we don't want to mix architectures. What happens is that if you log in on the copy partition, you won't see the same software you see on the compute nodes because that copy partition has a different CPU architecture. As such, there is a different hierarchy. That's why we have this concept of module hierarchy. That is the swapping between Zen 2 and Zen 3 is just handled by depending on whether you log in on the compute node or on the copy node. So just let me give you this. Give me 1 second. I'll show you what I mean. Okay. Now I'll show you my terminal. Now I'm currently logged in on a data mover node, and I do edit modular layer. What you can see here is that most of the things available are just the Cray provided software. But and the only thing that Pawsey installs are some of the utilities. Utilities are compiled for both Zen 3, Zen 3 and Zen 2. So you can see this is based on the Zen 2 architecture. We have China Squid here. We compile China Squid for the Zen 2 architecture because China Squid is a tool that we use to copy data in and out as well. And a few other things, but you don't see all the Aston applications, so you don't see all the other compute libraries because they're not used on the Zen 2 architecture. So this is what you see on the copy nodes. You don't see all the software available on all the other compute nodes. You can use the command module swap to move across branches of the module hierarchy, not for the architecture, because that's you cannot really run a different architecture, software compiled for a different architecture on the current one, but you can swap compilers. For instance, you could swap the MPI version, the library, and the HTML5, the HTML5 implementation using a few things are part of the hierarchy, and you swapping them, you can change the stack you're using. But this is somewhat an advanced use that is documented on our documentation. So it is an example. You can swap between the programming environment GNU and Cray. Let's say that this is what probably Igor does every time he logs in. He swap from the GNU to Cray.
Yeah.
And you can see that now the compiler has been replaced from GCC with the CC compiler, the Cray compiler. And because you changed the compiler, what changed also the Cray and Pitch implementation, the MPI. So now you're not using the MPI that was that is linked with GCC, you're using the MPI linked with the Cray compiler. And also the Python we have a Python installed for GCC and a Python installed for the Cray compiler. With the Cray compiler, you can see that that is reflected in the path where the Python is installed. The Python installed for the Cray compiler has the Cray compiler version on the path, but you have if you go back to the GNU environment, you see that now GCC is loaded back and the Python is reloaded to use the GCC version here. So this is not something is done every day, depending if you change the compilers. It's somewhat an advanced use, but something you can do. Let's go back to full view, and for this, I think this is the list of commands you can execute with module. It's the same. What else? Licensed software. I'm not aware of any licensed software MWA uses, but essentially we don't pay for software. So we provide software that is either unlicensed, or we provide software that is licensed, but you have to prove us that you have the license to run it. For instance, VASP is a molecular dynamics software that is as a license, kind of restrictive license, you have to pay for it. But we are in contact with the developers to say, look, we install the software on the system, but we only provide access to users who prove the license. And so if you are in licensed software, you have to bring your own license, and we will install the software for you if you need, but you need to depend also on the license. You have to take care of that essentially. We provide documentation on how to build and install software that is not part of the Pawsey software stack, but if it's a very complex software, it's just your own software, we don't really guarantee we can support that. It's up to the user. If you have your own software, you have to be able to compile it. The fact that we provide software such as WScreen or things compiled system-wide is kind of it's a way of relieving multiple users of the same tasks, and that makes sense. That makes sense to have it in the system because it's used by multiple users to recognize as an important software, and then we take that duty of providing it. But in general, users have to be able to install their own software. So we have user support documentation, which is regularly updated. And it's, I think that link, to be honest, needs to be updated. I think now we move to Atlassian, but this should redirect to the new link. We have just Google Pawsey user support documentation, and you have the link to the documentation. And of course, you can always open a ticket. Any question? Online, any question? Well, everything is clear.
These are details, right? So a lot of these differences will come when we start.
When you start using it, then you will have questions.
It's like there are quite a number of differences. Big one.
There are quite a number of differences, but I think on the software side, I think it can takes maybe a few days to get used to it, but you will soon realize the power of using a package manager just like Slack. For instance, Dev doesn't want to compile the software without Slack. Because now, for instance, to install WScreen, if you were to install it manually from scratch, you would have to install around 50 dependencies.
Right.
HDF5, Casacore. Casacore has its own dependencies, and it's a help.
Sure.
Now just one command is installed, and Dev and we spent a few months making sure that the registration packages are supported in this package manager.
Yeah.
So now it's much easier to install it if you have to install it yourself.
Yeah, that's one thing that will bring a lot of efficiency. But in terms of like the practice, one main thing that I picked up is that we have to start keeping track of the software version.
Yes.
In our whatever the scripts and jobs.
Yes, that is something that would bring more additional work. But when you have when you have an environment where we provide some software packages, and it's changing.
Yeah.
It's not it's not like Caravana that the software has been there for years. It's changes. When it changes every month, every 6 months.
Yeah.
And that version changes. We go from WScreen 3.2 to 3.5. Something changed, and you realize that.
Yeah.
You spend more weeks understanding why the data is different. So you have to keep track of that. It's something that happens, but I think it works well in the long term. But as Deva said, it just happens every day, every 6 months to a year. For instance, the last time we updated the entire software stack was in May, and we are planning sometime in February next year. So it's not a big deal after once you get used to it.
Yeah. So look, again, I'm just bringing an example that I was sort of connected with. Generally in astronomy, you are right. That we just want to see the image or detection and be done with it. But there are projects where the producibility is like a big issue, like pulsar timing arrays, which is like a long-running projects lying on several generations of backend and instruments and people, software. It's like one of them. So there, the reproducibility of data from say 10 years ago is like a big key, right? So there, people got into the practice of like keeping track of which software, which version, which command you ran, and which template you used, all that bit. Because without those kind of practices, those things will just fall apart, right?
Yes.
So there are places where people have embraced those changes, and here I think mainly, if I understand right, from the perspective of making sure that when we have an issue, you guys can sort of track it and help it resolve, right?
Yes.
And normally, whenever the new version comes, you will see an improvement in performance, because the new and updated libraries and optimized ones And if you see the other way around, then you can see, okay, when I use that version, it was different. So you can either go back or we can provide an alternative.
Okay, this is the last module. So we have around 25 minutes left. It's about containers. Using software containers, just like on Garawarla, you can run containers on Cetonix using pretty much the same technology. As a reminder, a container, what's a container? A container is basically it's a container is essentially is a file as it's seen outside, but it contains a deployment of a distributions of a Linux-based distribution that can contain the operative includes everything except the kernel. So it's based on an operating system such as Ubuntu, and then you have that you can install your own software in the container and bring that container around because it's just a file. It can be executed on any system who has a container engine software that can run that container. Everything within that file, so the software, the libraries, everything there will be run as if it were its own standalone virtual machine, let's say, and or let's say more than virtual machine, but like a standalone instance of the operating system. And the only thing that shares with the host is the kernel. So the kernel codes that happen within the container are passed down to the host. And essentially, everything within the container is isolated from the host that is executing it. So you can install your own software in a container and carry that container around on various systems that are based on Linux, and you can run that container and be fairly sure that results are reproducible. It's a good way to have it's a good way to package your software when the installation is quite complex, has many dependencies, and you need to run the same software on multiple systems. It could be a good idea to have it in a container. Although, as I said, with Spark, you can also consider installing software with Spark, as Spark provides dependency management. And many of the reasons why you would have a container, that packet management system kind of alleviated those issues. But so you could have some performance hit when you use a container. So there is advantages when using a container. But so you build it once and then use it on multiple systems. But the problem is that multiple systems have different computer architecture, CPU architectures, and different compilers. You can actually have a loss in performance. You're not reaching the maximum performance you get on a system because you didn't compile that software with the proper architecture. So what it turns out to be is that the container is good when you have applications that probably not, the performance is not really a big issue, or it can be compiled fairly optimized for multiple versions. But general for compiled software, even if you go from different architecture, we see that the CPU is quite different from the what you have in Garawarla. So it's always best to compile the software for a specific architecture. You can optimize a container for a specific architecture, but then you lose the portability. Yeah. So there are drawbacks in having that. Yeah. We do provide a container runtime Singularity to run these containers, but if you need to run complex workflows such as MPI jobs, jobs that rely on specific characteristics of the system you're running on, such as a supercomputer has this MPI as an MPI implementation and only works with that particular MPI implementation, then you have to start contaminating the container with some host information, and that also makes it less portable. So containers are useful. They're used very much on Cetonix, but also you need to consider these advantages and drawbacks, and consider whether installation on a normal installation on the system without containers could be a better option for you, especially using Spark. We have a large the largest use of containers on Cetronics is due to bioinformatics. So bioinformatics is relatively, let's say, new compute. Well, not in the terms of compute, they've been running computational workflows for years, for a couple of decades, but they were running on workstations. They only recently moving to supercomputing environment, but their software is, everything is a single core, is written to run on a single laptop or workstation, or it's often written in Python or R, so it's not a compiled language. So there are, one of the biggest problems in bioinformatics is that this has a huge dependency tree. So there are small packages put together, and even hundreds of them. And so that's where your container could be a good solution. It's a good solution for them because they don't have to install hundreds of packages. And many of those packages are also very niche. They are not widely used or supported. So compiling them, it's a real problem. So that's where containers are a good way to solve the problem. Also, deep learning frameworks, machine learning frameworks use typically containers because TensorFlow, PyTorch, that are Python, they are very complex systems. They have performance related low-level parts written in optimized C and C++, but then they have a Python interface that is also quite complex that can be used by users to write their own machine learning workflows. So it's a very complex work, and in that case, when you have many libraries that needs to be loaded at runtime, what happens is also you put quite a huge load on the file system to load all these files to be run executed every time. At every execution, you could even run easily tens of thousands of files when you run deep learning frameworks. So that's why we're having a container. It's good because it's seen from the file system perspective as a single file to be loaded. So it's also more efficient to load in memory. Okay, so we do provide Singularity. Singularity is, as you know, it's also Garavarla is a container engine to execute containers. You can run Docker containers with Singularity or Singularity containers, and we provide various versions. They differ mainly on what libraries from the host are made visible within a container. So if you need to run an MPI application, for instance, you want to load this MPI module because it exposes the MPI implementation on Cetronics within the container. If you were to load the no MPI version, then you wouldn't see the MPI inside the container. Why we need that? Because sometimes, sometimes the MPI libraries bring in some of the dependencies that conflict with what you installed on the container. So there could be conflicts happening when you mix the host environment and the container environment. That's why you want to just import the minimal set of things necessary for you to run your workflow with containers. And you have a few versions here. The reason why we have all these versions set up is for you to not to have to manually import the various libraries within the container. It can be kind of a tedious process. We have simplified it for you. Based on your use case, just load the correct Singularity implementation. If you have a problem, just submit a ticket to the Pawsey test, but we also have documentation helping you out. Okay. So I'm pretty sure everybody here has executed a container at some point. So if you want me to execute this demo, just tell me, otherwise I just move on. But the commands are exactly the same as Garavarla, nothing different. If you use container on Garavarla, then it's the same as Cetronics after you load the module. We do provide another difference is that not only we provide Singularity modules, we also provide container images where you can use to build your own containers. For instance, let's say you have an API application and you don't want to store. Having an API container, build an API container is not really straightforward. We provide a base image you can build on top of it, such that you can just take care of building your own application. But the API or the needed libraries to have that happening, it's already provided by your own container. So our documentations will point you to our repository. We provide containers which contain ROCM. If you want to containerize a ROCM a GPU application using ROCM, we have a container, ROCM container. We have a API container. We have Lustre container, so you can have Lustre inside the container as well. We have a few variations you can use to build your own container. So if you have I guess the most common one used is either the ROCM container. So just like you can have an NVIDIA container based on their featuring NVIDIA images, we have our own ROCM containers that is optimized for Pawsey, and you can use that. Same as for MPI. Another difference when you execute, another difference with NVIDIA containers is that to execute GPU-enabled applications, you don't need to pass any specific flags to Singularity, whereas if you run an NVIDIA container, you need the NV flag, just as a comparison. Okay. This is just an example of how you can pull a simple container. So it says, okay, I will load this Singularity version. I will download this Ubuntu 22 container, which it downloaded as a file. It's a CIF file. And then we execute the container. We run the container, and we want to run explicitly the cat command to see what type of Ubuntu you have actually downloaded. And you can actually see the information here. This is just an example of running a container on Cetonix. This is just an exercise. I will skip it, but nothing new compared to Garavana. Essentially, what is new with Garavana with respect to Garavana is container modules. Now, normally, if you want to run a container, you have to get your own container, download it, Singularity point. When you have this CIF file, you want to execute it with Singularity exec, container name, the command you want to execute. So I wouldn't say cumbersome, but it's quite a more verbose than running the application if you had an application installed there directly on the system, right? So you have to remember to load Singularity, the correct version of Singularity. You have to run find the file, the container file is somewhere, then you have to run the command in there, you have to remember all the Singularity options. So that when this becomes repetitive, you have to do the same thing, then there should be a way to kind of simplify the process. Then the idea behind container modules is this. We want to provide containers as modules, such that the commands within the container, if there are repetitive commands you particularly use all the time, then they are available as bash commands, and you would execute them just like normal commands, as if the program were installed on the system without containers, but under the hood, it's executed with Singularity. Now, we do that using a tool called Singularity Registry HPC. So what this essentially does, is just like Spark, you can write recipes to tell you, okay, how to build this software, and Spark installs the software. As HPC, what it does, you provide a recipe on how to download a container and what commands you want to execute within the container. And based on that recipe, it generates a module file, just like the other module files you have seen so far, and generates commands that are aliases to Singularity commands. Now, let me show you. Actually, I do have an example related to this. I'll show you and this one. So Bradley and I have been working on. Let's see. Change this one. We have. So let's say I change my default group to MWA. I log out and then log in again. Now, if Bradley is, let's see what module we have available. Now I log out and log in again. So you will see that we have this particular group of software here. That is installed for the MWA VCS project. Now I've seen this group of software because I'm part now of the MWA VCS. So whoever is part of the MWA VCS can see these modules. Now you can see there are a few modules here installed for people to use on Cetonix. And you can see there are, I believe these are modules that are actually containers. But let me show you what happens here. So if I want to load module load PSR timing, this module here. Now I should have available which Presto should be. Sorry, Presto is not Presto. I have tempo available, right?
Yes.
So if I run tempo just like that, it prints you the options you can use, right?
Yeah.
So it's like it's like any other software installed there. But what happens actually, if I do which one is tempo? So it points you to this location here, and you can see there is this container wrappers thing. And if we look in tempo, what happens is that tempo is not actually a binary, it's a script.
Yeah.
It's a wrapper script that calls singularity. Okay?
That's very nice.
So what happens is that you don't have to worry about
Yeah,
running singularity and
sure.
everything.
Right.
So what happens if I do module, I loaded this PSR timing module.
Yeah.
And then I can run Presto just like any other software. You don't have to worry about running singularity, finding the C files, all installed on the system with the module. Now, if I do module show this one, so it tells you a few things. It tells you what you can run, and now it's actually run. So it's a bit of a complicated. It's a fancy alias. So what happens is this module takes care of setting up all the various options that you need to run the software.
Yeah.
And it works 99% of the case, you don't have to interact with Singularity. You can actually, if you need to run Singularity explicitly, then you can still access the container and have everything available for you with a more advanced interface. But the 90% of the use case, you can just run tempo and it works.
But I think in the long run, even though right now it is not critical for us, but for the same reason I was giving that example, let us say that if we get into the world of like having a pulsar program, to for timing arrays kind of a thing. So this is the kind of things that will be handy because I might be running tempo, but in that it has all that information about what dependencies and software it has used. And that I think is just to capture that's a bit useful.
So you can see that it has this module as a version, so you know exactly what containers you're using.
Correct. Yeah.
So Bradley and I, for the VCS team, we work to create this kind of using this tool I was presenting here, SHPC. It's called to create the infrastructure to have this possible. And I'm not going to go and that deep into how to execute this. We have a documentation for that. But if you're interested in having such facility, we can work together and help you writing your own modules to execute Singularity containers as if they were normal commands installed. For tempo, it was necessary because we couldn't manage to compile tempo natively on the system because that Fortran core is quite old. And it was breaking with the fact that the paths now are very long.
Right.
And so we say, okay, we just have it as a container, but then to ease the use of the software, we just use this containers module system.
Yeah.
And Bradley liked it very much. They said, okay, I'm going to install all the post-processing software just like that.
Yeah.
But VCS Spring is going to be installed on the system because it's performance dependent API. But when you have complicated situation, this is another option. So you can use.
It's also easier because, like I was talking to you on the break, that when we sort of engage undergraduate students for like a semester projects or summer projects, we want to like give them like something self-contained. And so if we can like take away all these software hurdles from them and say that, okay, just use it this way, it's a lot easier. Otherwise, in the past, I think someone like a Bradley or someone else, Chris or somebody, Chris Jordan, will spend like a time installing and making sure everything is set up. But I think in the future, because we may not have, at least as of yesterday, and I don't think there is anything that is defined for continuation of things like Epimetheus. So we have to think about how we are going to engage undergraduate students in the coming year on summer projects or semester projects. So hopefully there will be like some solution, but at least this one helps to takes away one major hurdle, right?
And then you can, there are, for your own containers, most probably, there is no, let's say, SHPC recipe available. Like you have to write your own configuration files to make that happen. But there are very popular containers, for instance, PyTorch or other machine learning framework that have their own everything already installed. So it's matter to just run SHPC, install PyTorch or whatever popular container you want to run. In my experience for our users, it turns out to be, because they have their own containers, they usually have to write their own configuration files to make this happen, but it's just a simple text file. And we provide all the software necessary to make this happen. So you just need to write your own configuration file, specify what commands in the container you want to make it available, and then it will generate everything for you. This is it. For containers, any questions? Okay. But this
So out of curiosity, so Bradley, and you still have things to do as part of that uptake kind of path, or?
I think we've done quite a lot of progress. But we still optimizing this SPM, but
sure.
Yes, everything installed on the system, they can run it. We try to optimize it, but we made it possible to run the workflow on Cetonics so far. I think there is nothing left to do other than
the IO
optimization. Yeah,
that's an interesting problem, right? I still haven't quite fully understood why you have that, as like a big overhead. Anyway.
But this brings to the end of the training session for today, and tomorrow we can pick up again on where we left off with what's the next module?
Accounting.
Accounting model. So another big differences you want to notice, if you have a merit allocation on Cetonics, then you will be charged for the computer resources you're using. So it's good to know how this charging happening, what's the formula used.
Right. That's the other thing I'm looking forward to getting some slightly better understanding.
Yeah.
Because you guys know that I still don't understand those numbers in relation to what is defined as like a KSU or SU or NT or whatever, right?
And also we'll be looking at how to run jobs on Cetonics, which is quite different. It's user slum on both sides, but it's a bit different. So it's very important to know how to run jobs efficiently, because a small mistake can burn the entire allocation. The other day I was looking at one user, 32 nodes requested, 32 times 128. Okay. But using, in terms of SRun, using only 2 nodes. Right. So 30 node resources were lost.
Yes.
So the usage was quite good. So it's, and the allocation is exhausting.
That's a big new thing, I would say, that we have to get used to.
Yeah.
Because partly because we are also not quite used to that in any other place, like, the other resources that we go for supplementing our processing and the specific projects is things like NT. So there, if I say, okay, give me 300 KSU, and if project is good and track record is good, they will give, but I know more or less what is this good for, right? Because there the SU or KSU is like a little bit more comfortably defined, but I think here, from the sound of it, we need to sort of understand what it is, and we need to probably like a tweak the submission and this thing.
Yes,
There's a bit that to learn there, I think.
yes, but also we have the NWA partitions now as well available.
Yeah.
So understanding whether you need to use the NWA partition or you have your meritor location, things that different.
Yeah, but again, that's the one thing, that's right. But the part from what Deva was saying is that if you are not careful, you could be doing like a small job, but you could be like charged an inflated cost for completely, ignorance kind of a reason.
Yeah.
Right.
But depending on how you
That's the
use
new
it.
bit.
Yeah.
It's just one directive the user has added, and which
Yeah.
made a complete difference.
All right, if there are no any questions, I think we can call it to an end.
Yeah, please dial in tomorrow at the same time, 9 o'clock.
Yeah.
And
Thank
Yeah.
you.
yeah, bye everyone online.
Yeah, I think this was